With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi, the question is, a uniform square plate of mass 2 kg and edge 10 cm rotates about one of its diagonal under the action of a constant torque of 0.1 Newton meter. Calculate the angular momentum and the kinetic energy of the plate at the end of 5th second after the start. Alright, so before we solve this question, let us first discuss some key concepts that we need to know to solve this question. Okay, so the key concepts here would be the formula for angular momentum and kinetic energy. So formula for angular momentum is given by moment of inertia times angular velocity. Also, the kinetic energy in case of rotational motion is given by half times moment of inertia times square of the angular velocity. Here we need to find angular momentum and kinetic energy at 5th second. So the moment of inertia would remain same, but the angular velocity would change because we have a constant torque. So this would be at 5th second and this is also at 5th second. So we need to find angular velocity at the 5th second. So to find angular velocity at 5th second, we need to use kinematic equation for circular motion, which is given by omega equals omega naught plus alpha t, where omega is the final velocity, omega naught is the initial velocity, alpha is the angular acceleration, and t is the time. Alright, so we know time, we know omega naught, which is 0. So from here we can find omega if we have alpha. Now to find alpha, we have to use the third equation, which is the torque equation, which is given by torque equals I times alpha, where I is the moment of inertia and alpha is the angular acceleration. So in the question we are given torque, we can find I because we are given mass and geometry of the body. So we can find alpha from here. We can put alpha here to find omega. Once we find omega, we can put omega in these two equations, alright, to get L and K. Now let us proceed first to find moment of inertia, because to find alpha we need to find moment of inertia. So the moment of inertia for a square plate which is rotating about one of its diagonal is given by m L square by 12, where m is the mass and L is the edge length. So in the question we are given mass is 2 kg and edge length is 10 centimeter. So we need to convert this centimeter into meter. So mass is 2 times 10 centimeter. So it will be 10 times 10 to the power minus 2, and that is squared divided by 12. So from here we will get moment of inertia as 1 by 60 kg meter square. So let's call this as equation number 1. Now from torque equation we can find alpha. Now we have tau equals I alpha. So from here alpha becomes tau by I. Tau is torque. Torque in the question is given as 0.1 Newton meter. So we will put torque as 0.1 Newton meter and I is given by 1 by 60. So it will be 1 by 60. From here we'll get alpha as 6 radians per second square. So let's call this as equation number 2. Now we can use equation number 2 and the kinematic equation to find omega at 5th second. Now to find omega at 5th second, we will use kinematic equation in circular motion, which is omega equals omega naught plus alpha t. Now to find omega at 5th second, omega naught, which is the initial velocity, this can be assumed to be 0. So this will be 0 plus alpha is 6 and time is 5. So 5 6 are 30. So from here we'll get omega at 5th second as 30 radians per second. So this is equation number 3. Now we'll put omega 5 in our equation for angular momentum and kinetic energy. So now the angular momentum is given by I times omega. I is 1 by 60 kg meter squares and omega 5 is 30. So this will give us L equals 0.5 kg meter square per second. So this is our first answer. Now we'll find kinetic energy, which is given by half times moment of inertia times omega square. Moment of inertia is 1 by 60. Omega at 5th second was 30 radians per second. So this is 30 squared. Now on solving, we will get kinetic energy as 7.5 joules. So this is our final answer, and this concludes our solution. Angular momentum is 0.5 kg meter square per second and kinetic energy is 7.5 joules. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.